Alright, so I am cutting this video into two parts because unfortunately the space on our computers is not a lot. So it's going to have, instead of having 4 videos, you're going to wind up having 6. Okay. So this one will go from about 25 to 30 or 32. So let's get going. It's going to go really fast because I don't have that much time. All right. Here are the 3 graphs. Please look at everything that I did. I gave you just the answers to A and B and C. I broke it down using A, B, C, D. Okay. C was pi over 6. And then my period was endpoint minus starting point. So that gave me my period, which gave me my B. My high minus low gave me my A, and then my high plus low over 2 gave me my D. Therefore, this was my answer to the equation. Okay, look. You have the option of stopping and rewinding, but I'm moving on. All right, here is B. They said the amplitude is 3, period was 6, making the B pi over 3, phase shift of pi over 2, and they didn't say anything about a vertical translation. So here are all the information that you need. And as you can see, these were the answers to the equation. And I use x and theta, just basically showing you that they're the same thing. Take a look, because I'm changing the page. Alright, so this is A, B, and C. So this whole entire work here, I know it's a lot going on. This is the work for A. So take a look at that. You might want to stop, pause it, write everything down. This is the work for B. And the graph for B is over here. And then this is the work for C. Okay, unfortunately I don't have a lot of time to explain it. So hopefully you get the gist just by looking at everything that I wrote down. The only thing I will explain is how to get the 5 points without a calculator. Just knowing how to work with fractions. So this is 1/6 and plus 2/3 because that's your period. So it's almost like adding by 4/6, which gives you 5/6. So because I started with 1/6 and ended with 5/6, I kind of changed everything to 6s so that it allowed for me to get the other 3 points. Alright, here it was 1/4. And when you add 1/4 to 1/2, think about quarters. A quarter plus a half does give you 3/4. So I knew that we were going from 1/4 to 3/4. The middle would be 2/4. Problem is, between 1/4 and 2/4 is 1.5/4. So that's not going to work. So I pretty much changed everything to 1/8. That kind of allowed for me to see everything more clearly. And it allowed for me to get a middle number because in between 2/8 and 4/8 is 3/8. And then in between 4/8 and 6/8, which is what I have here, gives you 5/8. So this work here is just helping you get these two numbers. Okay, so study, look at it. Because unfortunately I'm going to change the page soon. Alright, this is simplifying expressions. So we have, this is the differences of signs. So look on your front packet. You'll see that it's the sign of A minus B. So just subtract these two. You get 2 pi over 8, which is pi over 4, which is the sign of 45, which is square root of 2 over 2. This is the cosine differences. Well, actually winds up being the sum of cosine because you know it's the opposite. So 5/6 plus 1/6 or 5 pi over 6 and pi over 6 gives you 6 pi over 6, which is just simply pi, which is the same as the cosine of 180, which is -1. Okay, look at it, pause it, do what you got to do. Alright, next up, these are the double angles. So we have the sine of 2a is really equal to 2 sine a and cosine a. They told us here that cosine was negative, so I kept it negative. And you wind up getting, using your triple, that's how you get 12 over 13, so I made it negative. And you wind up getting negative 120 over 169. Here I squared it, the negative dropped out, and we're left with 119 over 169. All right, study it, look at it, pause it. All right, identities, not really going to go into much, but this is the answer for A. Remember, with identities, your left side must match the right side, so don't touch the right side at all. Don't touch the right. So your main goal is your left and your right to match. Same thing over here. Notice when you see a 2 on the outside of a binomial, which are two terms being added, you have to actually FOIL it out. First, outer, inner, last. So when I FOILed it out, I had two identities in here. I had the trig identity here, which equals 1, and this is the double angle identity for sine. So I wound up getting the same thing on the left as I got on the right. So this is the answer to part B. And then part C is right here. The denominator is an identity. And I wound up getting cosine of x times over cosine squared x. So I separated the cosine so I knew I could cancel one of them out. And once you cancel something on the top out, you're left with 1. So I was left with 1 over cosecant, which really is sine. And my goal was to get sine. All right, so take a look at everything that I did. Alright, next part, you have to get the same denominator. So as you can see, I multiplied this by sine to get the same denominator as this, multiplying by cosine to get the same denominator. So I'm wind up with sine squared plus cosine squared. That's a trig identity equal to 1. So I'm left with 1 over sine squared and cosine squared. I separated them, so you can do that with multiplication. So 1 over sine and 1 over cosine does equal secant and cosecant, which is what I wanted in the first place. Okay, so this is the answer to D. Alright, E is down here. It's pretty long. So E, I expanded it. This is the sum expansion. This is the difference expansion. So you're not always using trig identities. Sometimes you're using sum and difference identities. So I expanded it, and when I did, I noticed these two were the same. So I canceled them out, and I'm left with sine x, cosine y, which are two of the same exact things. So I put them together and just wrote 2 sine x, cosine y, which is what I wanted in the first place. Alright, last one. And the identities was f, and f is all over here. So I had to factor out. When it factor out, that means you divide both groups by the same thing. So I factored out a sine squared, and I was left with 1 plus tangent squared inside the parentheses. That's an identity. It's a trig identity, which equals secant. So I changed that to 1 over cosine. And notice that sine squared over cosine squared is tangent squared, which is what I wanted. Alright, so that concludes, wait, no, I can do 31. Okay, 31 will be the last question for this video. So you can see here that we have 2 sine theta equals negative square root of 2, divide by 2, and you wind up getting sine of theta equals negative square root of 2 over 2. So where in your unit circle do you have negative square root of 2? That's in the first and second. Oh no. Yeah, this is not the right answer. Good thing I'm changing it. Okay, where in your unit circle do you have negative square root of 2 over 2? So that is actually going to be in the third and fourth quadrant. So that's 225 and 315. Whew, good save. So these are no factoring here, just simple solving equations. All right, here minus the smaller variable first, so I'm left with 2 cosine theta, minus 5 on both sides to have balance. So I have one number and one cosine on that side. Divide by 2 and I'm left with cosine is equal to negative a half. And you'll notice that I'm doing the arc cosine, which is pretty much just saying what degree measurement for theta will give me negative 1/2 for cosine. So cosine is negative in the second and the third quadrant. So that's why 120 and 240 are the answers. All right. Well, sorry if I was speeding. Apparently, you got to have a lot of memory in your computer to make these videos. So, yeah. So, sorry for that. But hopefully you'll enjoy this little song going out, if it'll play. We like to party!